Hi everybody, it's Jeremy Kruger here. Today I'm going to take a little break from the F-sharp videos and I'm going to talk about asynchronous versus synchronous coding. A while back I created a video that gave a brief introduction to what asynchronous programming is and how it compares to synchronous programming, and I promised that I would do a demo and I never did that. So this video today, I had somebody ask for that follow-up video, so I am recording that and posting this for you all. So um, as I mentioned before, asynchronous programming is a way to help scale traffic for web servers. It allows the server to process more requests at the same time, as opposed to synchronous, which will tie up the thread making the request while it's doing I/O intensive tasks. So where you'll most often see asynchronous programming is when you're accessing a hard drive, when you're querying a database, or when you're making network calls. So what I did is I created just a silly little API example using Web API and wrote it in the traditional synchronous fashion. And then what I'm going to do is convert that to an asynchronous call so that you can see the difference and you can see what's required to actually make an asynchronous call. The code in the end is going to look very similar. There's not a whole lot of differences, and that's one of the things that I like about the .NET model for writing asynchronous code, is that it's very easy to follow, it's easy to understand. I hope you like it too. So let's go ahead and get started. First, I'm going to show you my my synchronous web API. It's a silly little example, not very practical for real world, but for the purposes of this video, it'll work just fine. So I have a controller called Search Bing Sync Controller for synchronous. And all it has a single get method, and it calls a synchronous service, and it calls the search method on that service. When we go to that service, it gets the Bing URL and then it crawls the Bing search page. I wasn't sure exactly how many links I was going to do for this, so it turned out I didn't need as many as I thought. Originally, I had it set up so that it could search multiple pages of search results, but in the end, all I needed to do was search the first 5 listings. So what it does, the get Bing URLs just simply returns a single URL, and this is a search for C# on Bing. If we click it, you can see what it returns. So I think there's 13 results that it returns on the first page, and for the purpose of this demo, I don't need to go past page 1. In fact, when it calls this, so it gets this Bing URL, and then it crawls that search page, and what it does is it loads, it comes down to crawl search page, it loads the document, the search page, and then it gets the first 5 results of that page, and it loads each of those 5 results. So this is to represent a very long-running task. Now, this specific example, if we go ahead and run it, you'll see it takes quite a while to run. Earlier when I was testing it was taking like 20 seconds or so to load the results. So let's go to search Bing Sync, and let's open up the developer tools, go to network, so that we can see how long the page takes. Hit that, and as it's loading, like I said, it was taking about 20 seconds or so to complete this request, and I did that just for demonstration purposes. Now in real life, this would be any slow request that you would make. So it could be a database call, it could be a network call, it could be reading the hard drive, anything like that. Those are all, relatively speaking, slow calls. Even if it's only 100 milliseconds, that's 100 milliseconds that your web server could be processing other incoming requests rather than waiting for the response. So see here, it took 19.45 seconds. Now, obviously, in real life, you hopefully don't have an API that takes 20 seconds to return a response, but I made it take a long time just for demonstration purposes. Now, I'm not going to get into the details of the code. I have this up on GitHub, and I'll post a link to that solution on GitHub so you can download it yourself and play with the code. But just know that that's what it's doing. And specifically, it's this load document. I have a web client and I'm passing a URL and I'm downloading the content synchronously. This is the specific line of code that is performing the synchronous action. So now what I'm going to do is convert this synchronous code into asynchronous code. So what I have done, I'm going to go ahead and stop the service. What I have done, if you look over in the Solution Explorer, is for every synchronous control class, I also have a matching asynchronous class. And so we have a sync controller and an async controller, and we have a sync service and an async service. Now, for right now, the code is the exact same. So I'm going to pull up the sync controller, I'm going to pull up the async controller, and we're going to load them side by side. So the code right now is identical. Now I'm going to do the same thing for the synchronous service and the asynchronous service. So I'm going to pull that up. All right. So now we have our code. Let me close the Solution Explorer so that you can see a little bit better. And as I mentioned, it's down on line 63 where the network call is being made. This is where it is actually downloading, going out to the internet and downloading the web page. So what I want to do is convert that from a synchronous call to an asynchronous call. So most of the time, this is probably a bad example that I picked this because it is one of the few exceptions. Most of the time, Microsoft has done a really great job. All of their asynchronous methods, it's simply the synchronous method followed by the word async. Now, if you look, there is a method download string async, but this is one of the few exceptions where you don't want to follow this rule. This is an existing method that existed prior to the task parallel library coming out. So the actual method you want to use is the download string task async. The way I can tell is if you look at the return type, this download string async returns a void, and the download string task async returns a task of string. When you're working with the task parallel library and the async and await, any async and await method is always going to return a task. It'll either return just a plain task, which is equivalent to void in the synchronous way of doing it, or it will return a task of t, which is the equivalent of turning a result in a synchronous method. So this specific one, we're going to take the task of type string, and it's going to this is now an async call. But we're not done, because if you look at content, content is a task of t, and we don't want that. We want the actual string. So we're going to use the await keyword to say that this is an asynchronous method, but we want to pause here. We do not want to continue until this task completes. So all a task is, it's a promise that you will get some sort of result in the future, similar to promises in JavaScript or Angular, similar to a callback in Node.js. So now that we added await, we're using an async method, we're added the await keyword, and we're getting an error that says that the await operator can only be used in a method that is marked with the async modifier. So what this means is, in our method, we have to add the async modifier to it. Now we add that, this error goes away, but we get another error. And this says the return type of an async method must be either task or task of t. Now it says you can use void. Technically you can use void, but it is not recommended. You should never use void as the return type of an async method. And the reason for that is, if you use void as a return type for an asynchronous method, the caller of that method has no way of knowing when that task completes, which is a bad thing, because you can imagine you would want to know when something is finished. So I'm going to modify this. Before it was returning an HTML document. Now it's going to return a task of T or a task of type HTML document. Now this method is done. So we have successfully converted this synchronous method for load document to this asynchronous method. At this point, our code would compile, well, not, this method is fine. This method has no compilation errors, but we're still not done. One thing is the Microsoft recommended best practice is that anytime you have an asynchronous method, you want to add the suffix of async to the end of it. This is for ease of use. When you're working in a big team, or especially if you're creating a class library that's going to be reused by lots of other people, you don't want to, when you're calling a method you didn't write, you don't want to have to drill down into every single method and try and figure out whether it's synchronous or asynchronous. So by using this naming convention of always adding async to the end of any asynchronous method, it makes it very easy to know which methods are synchronous, which methods are asynchronous. So I've now called this load document async versus load document. Now we need to convert these or rename these methods to call the async method. Now this is where it starts getting tricky. So when I first started learning about asynchronous programming, I thought that you could just change your code in one place, it'd be simple, it'd be done, you could move on. Unfortunately, that's not the case. Asynchronous code is kind of like a virus. Once you get a little bit in your code, it starts spreading everywhere. Because, as I mentioned, the most common places for using asynchronous code is when you're accessing the database, when you're accessing the file system, or when you're making a network call. Well, typically, especially with web services, web APIs, that's one of the last things you do. That's where the functionality of your API is actually implemented, is in the database, in the file system, or accessing the network. And once that method is converted to async, any other method that calls that method must also be converted to async. So if we come up here to the calling method, we have this load document async. We have this load document async. Now, if you notice, we're getting a warning here, and it says because this call is not awaited, execution of the current method continues before the call is completed. So what it means, because we don't have the await keyword on these two calls, it's going to fire off this task, but it's not going to wait for it to finish, and we don't want that to happen. So we need to add the await keyword in both of these instances. And now we're getting the same error as before. We get the error that it can only be used within an async method. So we have to add the async here. And now, oops, wrong place, sorry. We have to add the async modifier here. And now we're getting the error that it must return a task of T. So we're going to change that, convert it to a task of T. And we need to add async at the end of this. So I'm going to do a refactor, rename it, add async to the end. And now this method is converted to async. But where it is called up here, again, we have to convert this code to use the new asynchronous method. Now, unfortunately, with select many, there is no way, if you look up here at the synchronous method, there is no way to use select many with an async call, at least not that I'm aware of. If you all found a way to do it, that's great. Leave a comment below and let me know. So what I'm going to do is I'm going to create a new list of string, and I'm going to say do a for each loop being URLs, and I'm going to say await crawl Bing search page URL async Bing URL. Oops. I'm going to do result.add and then I'm going to return result. Now, for right now, I'm just going to comment that code out. And we are getting another error. Same error as before. By this point, you should know what to do. So I'm going to delete that. I'm going to add the async modifier. Then that gives us the same error as before. I'm going to return a task of list of string. And I'm going to rename this method to search async. And we're still getting an error. Cannot convert to string. Oh, okay, sorry. So I need to do add range. All right. And now that is converted. So now our service has been completely converted to an asynchronous service. But we're not done yet. We need to go to the controller. So there's the synchronous controller. Here's the asynchronous controller. And we need to use our async service rather than our sync service. And we need to use our async service here. And for demonstration purposes, I'm just knowing this up in production code. You'd obviously want to use dependency injection or something like that. We're going to use search async. Now, same issue as before, right? We need to await the service. We need to add the async modifier, and we need to add a task. Now, and get async. So, at this point, we have successfully converted our synchronous code to asynchronous code. We should be able to build this, so let's go ahead and build. And we get no errors. We're going to go ahead and run it. And here's our URL for the synchronous call. I'm just going to run that just to make sure it's still working. And while that is running in the background, I'm going to call our search Bing async endpoint. Now, before I do that, I'm going to open the developer tools. And if you remember, our synchronous call took about 20 seconds to complete. And so here's our synchronous call. It's done now. We are going to execute the asynchronous code as well. I've got developer tools open, and let's see how long it takes to complete. Now, a lot of people think that asynchronous is supposed to give you performance, so you might think that this will take less time. But once it completes here, my guess is it's going to take about the same amount of time, right around the 20-second mark to complete. So it took 15 seconds. I'm a little surprised that it's faster. In the past, when I was running it, it was taking about the same amount of time. But it's not a huge performance, right? 15 seconds is still a long time for it to complete. And the important part to remember about asynchronous code is that it doesn't make a single call faster. What it allows it to do is queue up multiple calls and process those additional incoming calls while it's waiting on this database call, the network call, the IO, whatever. The example I gave in my previous video was if you go to McDonald's and order a burger, the person at the cashier doesn't stand there and stare at you and wait for your food to get ready. They take your request, submit it to the kitchen, and then they take the next person in line. And that's how asynchronous code works. while it's waiting on the database traffic or the network traffic or the I/O traffic, it goes ahead and processes other requests. So that is where you get the performance improvement with asynchronous programming, is in scale, not the performance of an individual call. So 16 seconds, still it's a little bit faster. I'm surprised by that. I don't really know why that is happening. Maybe one of you all can tell me and teach me something there. But that is all I have for the synchronous versus asynchronous code. Now, I do have one thing that came across, or that I came across while working on this, that really surprised me, and I cannot figure it out. I'm going to go ahead and show you all this example that I created, and maybe one of you all know why this is happening. So if you do know, leave a comment below and let me know. But I'm going to search and try to figure out why this is happening on my own as well. So if we go back to the code here, I'm going to go ahead and stop it, and I'm going to close this out. What I wanted to do for this video was create a way to show you the benefits of asynchronous programming, but it actually backfired on me. So I created this load generator app, and all it is a simple console application, and it generates an enumerable from 0 to 50, and then it calls the API that number of times. This uses the asynchronous code, so it fires these 50 requests off in parallel to simulate a bunch of load on the API. And you have the option, it asks you, do you want to run this asynchronously, yes or no? If you say yes to run it asynchronously, it calls the async endpoint. If you say no, you do not, it calls the synchronous endpoint. So when I run this, what I expected, I'm going to edit my solution. What I expected to happen was that the synchronous code would time out and not be able to handle all of the requests, but the asynchronous code would be able to handle it. And in fact, the opposite happened. And I'm still extremely confused by this, and I don't understand why. So let's run this, and we can ignore that. All right, so it's asking, do we want to run asynchronously? I'm going to say no and run it. So this is firing off, it's queuing up the 50 simultaneous requests, and it is firing them off to the synchronous endpoint. The 11 is the number from 0 to 49 of the request, and then it's going to either say success or failure if this call to the API completed successfully, and it's going to return the total response time. So this was a success, it took 11 seconds. The number 6 was a success, it took 28 seconds. 5 was a success, it took 32 seconds. So we're just going to let this go ahead and run. It takes about 2 minutes, because after about 2 minutes they start timing out. So as you can see, they are completing. They are, because so many requests went in, they are slowing down the service. So you can see that this is taking a lot longer, 72 seconds for the most recent one that completed. This is taking a whole lot longer than the 20 seconds or so that it was normally taking when we had just a single one go in at a time. So we're up to 83 seconds, 88. Up to 111 seconds. So pretty soon we're going to see a whole bunch of them complete all at once, and they're all going to say failure because they reached that point where they timed out. So you can see this is pretty much exactly what I expected to happen with the synchronous call. About half of them were successful and about half of them failed. That's what I was expecting. I was expecting the synchronous API to get overloaded and to not be able to process all of the requests. So it's asking me, do I want to quit? I'm going to say no. It's going to go back and start over. So now, do you want to run asynchronously? I'm going to say yes. So this time it is calling the async endpoint. Now, while the synchronous did what I expected it to, I thought that the asynchronous would be able to complete all of these requests. I expected all of them to say success, or at least more of them, a much higher percentage to complete successfully. But as you'll see here, the exact opposite happens. A very small percentage actually succeed, and the rest all fail. Um, and I really this has me confused. I do not understand why. So if you know why this is happening, then please let me know. Otherwise, I'm going to continue to do some research, and once I find the answer, I'm going to um, make an additional post about it and let you know. While this is running, I'll come back to it. You can find this code if you go to github.com/jcrewer01/sync verse async. This is a public repository, so you can clone this and you can get the code and play around with it yourself. But go back here. Now, when I ran this before, there was probably only about 5 to 10 of them that were actually successful. So it's already more than what I expected, or what the results I was getting previously. If we look, so in the synchronous, we had one. It's going to keep bumping up while that's completing. So let's just wait here a minute. All right. So in the synchronous call, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So exactly half of them were successful. In the asynchronous, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Wow. All right, so we had exactly the same. So this isn't, it's the power of video, I guess. But when I ran this before, it was only about 5 to 10 of them completing on the asynchronous. But still, because of the asynchronous, I would have expected 75 to 100% of them to complete successfully. So if you know why that's happening, leave a comment below. Otherwise, stay tuned, and once I get the answer, I will make an update and let you all know what I find out. But that's all I've got for today. Hope you enjoyed this video. If there's anything else you'd like to see, please leave a comment below to let me know. And also don't forget to subscribe so you can always be notified of all the new content that I post. Thanks a lot. Have a great day.